Take a look at this. Two images, same application. One is a monster 2.29 gigabytes. The other is just 134 MB. Imagine which one you would want in your CI/CD pipeline. In this episode, I'll show you exactly how I created this bloated image and how we shrink it down using multi-stage builds. Stick with me. By the end, you will know how to build fast, production-ready images like a real DevOps engineer. If you are new here, hit subscribe right now. Every week, we don't just run Docker, we break it, optimize it, and debug it, just like you will have to in production environment. In a naive Docker file, you start with a heavy base image, then install way too many dependencies and copy unnecessary files. That's how you end up with 2+ gigabyte of image. In a slim multi-stage build, you only keep what's needed to run the application. Result, a tiny and efficient image. Now let's jump into the demo. So here's my episode 7 image optimization folder. In this folder, I have multiple files: Docker ignore, application.py, Dockerfile bloated, Dockerfile optimized, requirements.txt. We are going to start with Dockerfile bloated version. So if you look here, we are starting with Python 3.10 with big base image with lots of extras, followed by working directories like application directory. Then we are going to copy everything. I do not even have .docker ignore here. Followed by installing. We are trying to install compilers, JDK, Node, Yarn, React CLI plus heavy Python libraries. Most of this is not needed in production environment. Followed by exposing our port and just run our application. So we just installed a full development environment inside our image. That's why it explodes past 2 gigabytes. Let's try to build that real quick. I'm going to build that image now with docker build -t flask fat name with a version 1 tag and the Dockerfile bloated. Press enter. And here it is. Slow to build, slow to push, slow to deploy. This is what happens when you don't optimize. It will take a lot of time. It depends on the speed, network bandwidth and all. I'm going to wait. Till then, let's discuss about Dockerfile optimized version. So we start with our builder stage. Notice I'm using Python 3.10-slim, not the full Python 3.10. The slim image strips out unnecessary system tools, make it smaller and faster to pull. I also give this stage a name builder. That way I can reference it later. Working directory. This means all future commands run inside application directory. Standardizing the working directory keeps everything clean and predictable. Here's the key. In the builder stage, I install temporary build dependencies like build essentials, GCC. These are needed only for compiling certain Python libraries. But notice, immediately we are trying to clean up. That removes the apt cache, preventing extra MB from sneaking into the image. This is a best practice. Install what you need and clean up right away. Next, I copy in only the requirements.txt file. This is important because Docker caches layer. If I copy all the code first, any change would break the cache and force pip to reinstall everything. By copying just this file, I only trigger reinstall when dependencies change. Then I run pip install -- user no cache directory. User means install packages in the user directory, not system wide. No cache directory avoids keeping pip's cache which saves disk space. Final copy. I copy the rest of the application code. This happens after dependencies, so code changes don't invalidate pip cache layers unnecessarily. Again, it's all about faster builds and smaller layers. Now for the second stage, runner, I start with fresh from a clean Python slim image. This stage has no compilers, no build tools, nothing unnecessary. It's production ready. Same as before, working directory. First, I copy the installed Python packages from the builder stage. Then I copy the actual code. Notice how we don't compile apt tools or caches, just the dependencies and code. This is why the final image is so small. This line updates the path so that the installed Python packages are available. Without this, pip installed user packages wouldn't be found. This ensures Flask and other dependencies can run correctly inside the container. Finally, I expose port 5000, the default Flask port, and set the command to run the application clean, minimal, and production ready. Now let's try to build our slim image. For that, I'm going to run docker build flask -slim v1. I'm going to use Dockerfile optimized here. Press enter. Let's start with the fat image. Press enter. If you see this, I can see my fat image got built successfully, but the size is 2.29 gigabytes. That's how big it is. Now let's look at our slim image. Press enter. 134 MB. You see the difference? 2.29 gigabytes, 134 MB. If you look at our bloated file, I have around 25 lines of code and it gave me 2.29 gigabytes of file, whereas optimized also has around same 26 lines of code and I got 134 MB. Now let's try to inspect the layers. For example, Docker history. Docker history will show you the layers. V1, if you look at the layers, here I can see 120 MB, 60.2 MB, 656 MB, followed by I can see 1.2 gigabytes here. Okay, this particular layer is taking 1.2 gigabytes. Let's look at our slim image history. I'm going to clear the screen. Press enter. So if you see here, everything is in MB. I don't see anything like gigabyte here because we wrote production ready multi-stage build Dockerfile. You might be thinking, why am I stressing so much about this size? In real production environment, smaller images is equal to faster CI/CD pipelines. Okay, this is one of the most important point you need to remember. Less network transfer is equal to cheaper bandwidth, followed by smaller attack surface is equal to better security. And imagine debugging a crash with a 2 gigabytes pull versus a 134 MB pull. Which one would you rather deal with? Comment below. Now let's do a quick recap of today's episode. A bloated Docker file with a fat base image plus unnecessary tools is equal to 2.29 gigabytes monster. Multi-stage builds let you separate build dependencies from runtime. Slim base image plus .docker ignore plus copying only what you need is equal to production ready images. In the next episode, we will talk about container security and permissions. You will see why running as root inside a container is dangerous, and we'll break an application with permission errors to learn how to fix it. Hit like, smash subscribe, and don't miss it. Thank you for watching and see you in the next video.